Hello students, in this video we're actually going to be talking about something that I really enjoy, and it is the division of polynomials. And this is something that I actually find pretty fun to do. The idea here is that we've learned, somewhat how to divide polynomials, and we've gotten to a point where we said, if their terms don't look exactly alike on top and bottom, that we are unable to fully simplify down the polynomial. Well, now we're going to do the process of long division in order to find factors of polynomials. So let's just refresh our memory, because it's probably been a long time since we've done the division of polynomials, or the long division of just regular numbers. If I had 426 and I wanted to divide that by 2, if you remember long division, you have that little house thing. And what we do is we say, okay, what number, here in yellow, what number times this 2 will give me this value of 4. And so I say, okay, well, 2 times 2 would give me 4. And you notice that I've placed the 2 over the 4 because that's the only value I was considering. And that gives me 4, and I subtract those values. 4 minus 4 is 0. And then I bring down what is left over. And then I do the process again. What number times 2 will give me 2? And so I say, okay, well, 1, because 1 times 2 is 2, and I subtract those, and they go away, bring down what's left over. And now, what number times 2 will give me 6? Well, 3 times 2 will give me 6, and I subtract those, and they go away. And so when I'm left with nothing at the end, there's nothing else to bring down, that's called my remainder. And in this case, I have no remainder. That means it's a perfect value. So 2 perfectly goes into 426 213 times. And 213 is called my quotient. Okay, so that's just a quick little review of how to do long division. So some things to remember. So some important things you want to make sure you're doing. You want to make sure that you are lining up your columns. So you'll notice that I was very neat with my work as I wrote out particular values. I made sure that they were lining up under each of their columns. When I multiplied the 2 times 2, I put it solution 4, right below the 4. I was just very neat and precise, and that's necessary. You're going to want to put in placeholders, and that's not going to make sense right now, but we'll have an example where it does. But you want to put in placeholders when necessary. And then we always want to make sure that when we're working with polynomials, again, this didn't apply in this example we just did, but whenever we're working with polynomials, we want to make sure that we put our polynomials in descending degree order. Very, very important. So these little 3 tips, I encourage you to write those at the top of your paper or somewhere easy to look at as you go through each of the problems that we're going to do. And through this entire lesson, I'm literally just going to keep doing examples, because I think that you learn and become comfortable with this, when doing examples. As always, I encourage you to pause the video when you feel comfortable. Try to do things on your own. I'll try to pause to give you a good place to stop the video and try to complete the problem on your own. But if you're just watching me do it, you're more than likely not going to sufficiently learn the material. So make sure you're actively solving the problem as well. So let's say my first example is the polynomial n squared plus 4n plus 4. And let's say I want to divide that by the binomial n plus 2. So I'm going to go ahead and set up my problem. N squared plus 4n plus 4. I'm going to divide by n plus 2. And I'm going to look at my things to remember and ask myself, have I lined up all my columns? Well, I'll do that as I go. Do I need to put any placeholders? No, because this is perfect descending degree order. I'm going from n squared to n to a number. Okay, so I'm focused on that inside polynomial and asking myself, is it in perfect descending degree order? If it is, then I'm good, because I've put it in descending degree order and I don't need any placeholders. Okay? All right, so now I want to think about what number, so what value times n will give me n squared. What number times n will give me n squared? Well, I know that that is n. And you may be wondering, well, why didn't you put that right above the n squared value? Well, n times n gives me n squared. But notice this is n to the first degree. And so I want to put n to the first degree in the column of all of my n's to the first degree. Okay? So n times n is n squared. I subtract. N squared minus n squared goes away. And I'm going to bring down everything that's left over. Oh, wait. No, I'm not. I lied. Just kidding. Sorry. All right, let's try that again. So n times n is n squared. I forgot what I'm doing here. Then I'm going to take n times 2, which is 2n. Sorry about that. So I want to make sure I do n times n, and I get n squared, and then n times 2, which is 2n. And now everything has to subtract. So I'm putting a subtraction here and here. N squared minus n squared goes away. 4n minus 2n is 2n. And bring down what's left over. Much better. And now I'm going to ask myself, okay, what number times n will give me 2n? Well, a 2, so I'll do that in blue. 2 times n will give me 2n. 2 times 2 will give me 4. And I want to subtract everything, so minus and minus. 2n minus 2n goes away. 4 minus 4 goes away. So I have a remainder of 0. And you'll notice it looks a little weird at the top. I just have that 2. Well, what is that? It's a positive 2. And so what I find out is that my answer or my solution to n squared plus 4n plus 4 divided by n plus 2 is n plus 2. Well, why does that make sense? Well, what is n plus 2 times n plus 2? N squared plus 4n plus 4. And so what you should hopefully notice is that n squared plus 4n plus 4 is the original problem that I started with. Right? So what I'm doing is I am finding the factors of n squared plus 4n plus 4. When I'm told I know one factor is n plus 2, go find the other factor. Okay? That's called defactorization, when I break down all of my factors as much as I can. Okay? All right, let's do another example. So let's do 2x squared plus 3x minus 14 divided by x minus 2. And I just wanted to set this up differently to show you another way that the problem could be worded. So 2x squared plus 3x minus 14 divided by x minus 2. I'm going to think about my things to check. So placeholders, do I need any? No, because I'm in perfect descending degree order, which is x squared, x, constant. And I'll make sure I line up my columns as I go through the problem. So what number times x will give me 2x squared? What number times x will give me 2x squared? Well, 2x. And again, notice I'm lining that up in the x column. 2x times x is 2x squared, and then 2x times negative 2 is negative 4x. But I have to subtract everything, so this becomes a minus, and because there's already a minus, now it becomes a plus. First terms go away, 3 plus 4 is 7x, bring down what's left over. And now I do the process again. What number times my x will give me 7x? Well, I get 7. That's a positive 7. Times x gives me 7x. And positive 7 times negative 2 gives me negative 14. But I have to switch all of my signs. So that becomes a negative, and now that becomes a positive. And this goes away, so I'm left with nothing. Therefore, I have found that 2x plus 7 times x minus 2 gives me the solution 2x squared plus 3x minus 14. Okay. All right, let's look at another example. M squared minus 7m minus 11 divided by m minus 8. So I notice I'm in perfect descending degree order, so I'm good on that. I'm dividing this by m minus 8. So what number times m will give me m squared? Well, m, and notice I'm lining that up in the m column. M times m is m squared. M times negative 8 is negative 8m. But all my signs need to switch. And this goes away. And negative 7 plus 8m is just 1m. Bring down what's left over. And so now, what number times m will give me m? Well, that's just a positive 1. Because 1 times m is m, and 1 times negative 8 is negative 8. I need to change all my signs. So this becomes a negative, this becomes a positive. First term goes away, but on my second term, I'm left with negative 3. So now I actually have a remainder. So we don't want to just leave our remainder down there. It is part of our answer. You may have remembered back in the day you would write r negative 3 like that. We are not doing that in this course, okay? When we get into upper level math and we do division of polynomials, actually what we need to do is we are going to add a fractional value. In my numerator is going to be the value of my remainder. I want to make sure you note that in this example, my remainder is a number. But it is okay for my remainder to be a variable or a binomial or even a trinomial. It is possible. So you could totally have variables. And then the bottom value, the denominator, is going to be what I originally divided by, which was m minus 8. So I'm adding that fractional value. So what I got as an answer here is that m minus 8 times this terrible polynomial of m plus 1 plus negative 3 over m minus 8 multiplies together to get me m squared minus 7m minus 11. But what this lets me know is that m minus 8 is not really a factor of this quadratic polynomial because I didn't get perfect solutions since I got remainders. So therefore, it is not a factor. Okay? As always, I'm going to encourage you to pause the video and work through this one on your own. What number times n will get me n squared? That would be n. I'm making sure it's in the n column. And n times 5 is positive 5n. But now all my signs need to switch. And my first term goes away. I'm left with 5n. Bring down my plus 18. Now, what number times n will give me 5n? That's a positive 5. 5 times n is 5n. 5 times 5 is 25. But I want to make sure I change all my signs. So a minus and a minus. First term goes away. And 18 minus 25 is negative 7. So I'm going to take my remainder. I'm going to add a fractional value. My remainder goes in the numerator, so negative 7. And what I divided by goes in the denominator. All right, I want to look at another one. Say I give you negative 5 plus x plus 2x cubed plus 3x to the 4th plus 4x squared. And I ask you to divide that by x squared plus 2. You'll notice that this numerator value, so that's going to be on the inside of my division sign, is not in descending degree order. So I'm going to want to make sure that I put it in descending degree order. So 3x to the fourth plus 2x to the third plus 4x squared plus x minus 5. And then you'll notice that the outside value, x squared plus 2, is missing the x on the in the middle of the polynomial. You can put a placeholder here if you would like, but it's not a big deal. Placeholders really, really matter when you are looking at the inside portion of the problem, okay? So when I say line up columns, it's really going to come into play here. So what number times x squared will give me 3x to the fourth? Well, I know that 3x squared times x squared will give me 3x to the fourth power. Notice that I put this term in the x squared column. And then when I go to multiply 3x squared times 2, I actually end up with 6x squared. So notice that this value here got skipped. So I can either put a +0 or draw my arrow down to refresh my memory or make sure I don't forget that that term is going to come down, but right now I'm not doing anything to it. And now I'm going to subtract my terms. These go away. I brought down my 2x to the third. This is minus 2x squared, and bring down everything else, plus x minus 5. And now I want to think about what number times x squared would give me 2x to the third power. Well, that's just 2x. So that's in the x column. 2x times x squared is 2x cubed. 2x times 2 is 4x. Again, notice that I've put that in the x column, so I can either put a 0 or draw an arrow so that I don't forget that I skipped a term. I'm going to change all my signs and then simplify. Bring down my negative 2x squared. This is a negative 3x, and bring down my minus 5. And then last value, what times x squared will give me negative 2x squared? Well, a negative 2 gives me negative 2x squared. Negative 2 times 2 gives me a negative 4. But I want to change all my signs. So that becomes a plus and a plus. That goes away. I skipped a term, so I'll bring that down. And I am left with the remainder of negative 3x minus 1. So this time we have a polynomial. Same idea. I'm going to add a fractional value where the value of my remainder goes in my numerator and what I divided by goes in my denominator. Okay? As always, I hope that you found this video helpful. If you have any questions or concerns, please, please, please don't hesitate to reach out.